Hello, good evening students. We can go through the questions from the chapter Alcohols, Phenols and Ethers. It is a revision session. Let us see the questions one by one, right? See, the first question, identify the end product S in the following sequence of reactions. Reaction is CH3 CH2 MgBr, that is a Grignard reagent that is treating with a cyclopentanone. Cyclopentanone is a ketone. The product, the intermediate thus obtained is subjected to acid hydrolysis to get a product P. That on treatment with HBr gives another product Q. That on reaction with the magnesium in ether produces R. R on reaction with the methanol followed by acid hydrolysis gives S. Identify S. These are the options given. We can see the sequence of reactions here. Cyclopentanone is treated with a Grignard reagent, that is CH3 CH2 MgBr. You know that Grignard reagent on reaction with a formaldehyde produces a primary alcohol. Grignard reagent reacts with any aldehyde other than formaldehyde produces a secondary alcohol, while Grignard reagent reacts with a ketone produces a tertiary alcohol. Here first step, this is nucleophilic addition reaction. This is the first intermediate formed. MgBr is connecting to this oxygen, and here this carbonyl carbon is bonded to one ethyl group. This on hydrolysis produces, when it is hydrolyzed, you will get a product alcohol. That on treatment with HBr here, that on treatment with HBr, alcohol with a hydrogen halide, halogen acid. First step, protonation of the OH group, then elimination of water to get a carbocation. That carbocation will be attacked by the nucleophile. So here Br will be connected and CH2CH3. This on further reaction with the magnesium produces another Grignard reagent, that is MgBr. Here CH2CH3. This on reaction with methanol. This on reaction with methanol is CH2 double bond O, followed by hydrolysis. You will get a primary alcohol. Any Grignard reagent with the formaldehyde produces a primary alcohol. To get the product, connect this hydrocarbon segment here, and here CH2OH, and it has got one CH2CH3 group. This is the final product S. See here, many reactions are clubbed together. So to get Grignard reagent with the cyclopentanone forms a product that on acid hydrolysis gives P. P on treatment with HBr gives Q. That on treatment with the magnesium in ether followed by reaction with the methanol and hydrolysis produces S. So the answer of this question is option C is your answer. Option C is your answer. C. Answer C. Option C is your answer. Okay. Next question is very important type question. Another one, dehydration of the given alcohols. Alcohols undergo dehydration. During the dehydration of alcohols, first step, protonation of the alcohol. Second step, removal of water to form a carbocation. That carbocation then undergoes deprotonation, giving an alkene. During the dehydration of alcohols, we get alkenes. Since during this reaction, during the dehydration of alcohols, intermediate formed is carbocation. That is very important. During the dehydration of an alcohol, CH3, CH2OH, that on treatment with concentrated sulfuric acid, on strong heating, first step protonation of the alcohol. Second step, removal of water, elimination of water to get a carbocation. This is the second step, carbocation. During dehydration of alcohol, carbocation is the intermediate, that is very important. Therefore, rate of dehydration proportional to the stability of the carbocation. You know that tertiary carbocation is more stable than secondary carbocation is more stable than primary. So you have to say that any alcohol that can produce a tertiary carbocation undergoes this reaction faster than that one which can give a secondary carbocation. The one that can give a primary carbocation undergoes this reaction at least at a slower rate. So here carbocation is formed. This then eliminates H positive ion from its alpha carbon to get a double bonded molecule. So in this reaction, during the dehydration of alcohol, the reaction giving the carbocation is supposed to be the slowest step, that is the rate determining step. So here remember that during the dehydration of alcohols, reactivity of alcohols proportional to the stability of the carbocation. Just remember, any alcohol that can give a more stable carbocation undergoes this reaction faster. We know that stability order of carbocations, tertiary greater than, secondary greater than primary. Therefore, among these, normal butyl alcohol, that is primary, tertiary butyl alcohol is secondary, it is a primary alcohol, it is a tertiary alcohol, it is a primary hindered primary, it is secondary alcohol. Therefore, the reaction rate, you know the answer now, tertiary, second one is more reactive than, then secondary, fourth one is more reactive than, then more hindered primary, that is third one more reactive than first one. So option is 2 greater than, 4 greater than, 3 greater than 1. Option A. A is your answer. A is your answer. So answer of this question is option A. Okay. Next is third question. Reactivity order of alcohol towards esterification, follow the order. You may know the answer, very simple. Tertiary greater than, secondary greater than primary. Second option, primary greater than, secondary greater than tertiary. Third option, secondary greater than, tertiary greater than primary. And the last option, primary greater than, secondary greater than, primary greater than, tertiary greater than secondary. To get the answer, you have to know what is esterification. Esterification means when you treat an acid, carboxylic acid, with an alcohol. RCOH is a carboxylic acid. When a carboxylic acid is treated with an alcohol, alcohol can be written as HOR dash. In the presence of concentrated, little bit of concentrated sulfuric acid, there will be removal of water to form RC double bond OR1. This is ester. It's a fruity smelling compound. Just you see the reaction from the equation given, it is very clear that during esterification there will be the cleavage of carbon OH bond of the acid and there will be the cleavage of oxygen-hydrogen bond of alcohol. That is important. During esterification, carbon OH bond, carbon OH bond of acid undergoes cleavage, while in the case of alcohol, OH bond undergoes cleavage. So here lies the answer. ROH during esterification of an acid with alcohol, during the esterification reaction, there will be the cleavage of OH bond of alcohol. OH bond of alcohol undergoes cleavage readily. The rate of cleavage of OH bond proportional to the polarity of the OH bond proportional to the acidic strength of the alcohol. So any alcohol that has got a greater polar OH bond that becomes more acidic, that undergoes this reaction faster. Among the various alcohols, you know that acidic strength of alcohols follow the order. Primary alcohol is more acidic than secondary alcohol, more acidic than tertiary. Do you know the reason? The reason is this is primary alcohol. Compare the polar nature with water, HOH water. There is OH bond. OH bond is polar. Here there is post-electron deficient hydrogen. Here there is negative charge. When you consider an alcohol, it is a primary alcohol. This bond is polar in nature, but due to the plus I power of the alkyl group, there will be higher electron density around the carbon atom holding the OH group. Because of the higher electron cloud, this oxygen atom becomes less electronegative. This bond becomes less polar. So alcohols are weaker acids than water. So it is primary alcohol. Which alcohol is more acidic, primary or secondary? In the case of secondary alcohol, this is a secondary alcohol. This alkyl group is electron releasing, electron donating group. This also electron donating group. There will be greater electron density around that carbon atom. As a result, higher the electron cloud around this oxygen atom. This oxygen becomes less electronegative than this one. So this bond is less polar. It is less acidic. So among the various alcohols, it is very clear that primary alcohol is more acidic than secondary alcohol, more acidic than tertiary alcohol. During esterification, the reactivity of alcohols proportional to the acidic strength of the alcohol. Therefore, the answer is very clear. Primary alcohol undergoes esterification more readily than secondary alcohol, more readily than tertiary. So this is your answer C. Answer is option B. Next question is identify X and Y in the following sequence of reactions. You are provided with a compound that is C4H10O, that is denoted as X, that reacts with the Lucas reagent very readily at room temperature, very readily reacts with the Lucas reagent at room temperature, giving a product Y. Y on treatment with alcoholic KOH produces 2-methyl propene. Options, you see the options, A butan 1-ol and 1-chlorobutane. Option B is butan 2-ol and 2-chlorobutane. Option C is 2-methyl propan 2-ol, 2-methyl propan 2-ol, 2-methyl propan 2-ol and 2-chloro 2-methyl propane, and last one 2-methyl propan 1-ol, 2-methyl propan 1-ol and 1-chloro 2-methyl propane. Okay, see, to get the answer C4H10O. C4H10O, this is the way to get the answer C4H10O. It belongs to the general formula CnH2n plus 2O. CnH2n plus 2O is the general formula of alcohols and ethers. So C4H10O it is an alcohol. Among the various alcohols, alcohols react a different rate with the Lucas reagent, or different alcohols undergo reaction with the Lucas reagent at different time intervals. Any alcohol, so among the, it is an alcohol. Alcohol means it has an OH group. The remaining part is C4H9. C4H9 is butyl group. Butyl group may be n-Butyl group, secondary butyl group, isobutyl group, and tertiary butyl group. So this is an alcohol. Among the various alcohols that can be obtained from C4H10O, only tertiary alcohol reacts very readily with the Lucas reagent. So it should be a tertiary alcohol. Tertiary alcohol is this one. This is tertiary butyl alcohol, or it is 2-methyl propanone. 2-methyl, it is the tertiary 2-methyl propanone. It is a tertiary alcohol. This is X. This on reaction with the Lucas reagent. You know what is a Lucas reagent? Lucas reagent is a mixture of concentrated HCl and anhydrous zinc chloride. When it reacts with the Lucas reagent, concentrated HCl and anhydrous zinc chloride, you will get a turbidity of alkyl chloride very readily. CH3, CH3Cl. So this is Y. This is the halogenated compound that is formed. It is 2-chloro-2-methyl propane. 2-chloro-2-methyl propane. So we can see the here this is an X is 2-methyl propanone, and Y equals 2-chloro-2-methyl propane. So answer of this question is option C is your answer. Very good question. And another one is iodoform test is not answered by. Iodoform is CHI3. You may know the answer of this question. Normally, this type of questions are frequently in their entrance question paper and all. Iodoform reaction is very important. Iodoform is yellow crystalline substance. Iodoform is formed when any one of the following is treated with iodine and alkali. Iodine plus alkali, when you treat any one of the following with that is very important. When you treat any one of the following with iodine and alkali, you will get a yellow colored substance, that is CHI3, that is iodoform. This any one of the following means that is very important. Among primary alcohols, only ethanol. There are so many primary alcohols. Primary alcohols are compounds having CH2OH group. Among the various, among the different primary alcohols, only ethanol can give this reaction. Iodoform reaction will be given by ethanol among primary alcohol. And among secondary alcohols, this is CH3, CHOHR. It is a secondary alcohol, or it is alkan-2-ol. There are so many types of secondary alcohols. Among the secondary alcohols, only alkan-2-ols. Alkan-2-ols. It is alkan-2-ol. It is alkan-3-ol. Whatever may be, it is alkan-3-ol. 1, 2, 3, 1, 2, 3, 4. It is alkan-3-ol. It is secondary alcohol. So remember, among the different secondary alcohols, only alkan-2-ols, or you can say that any secondary alcohol having CH3CHOH group, any secondary alcohol containing CH3CHOH group can give haloform. Here it is iodoform on treatment with iodine and alkali. And next one, and among aldehydes, only CH3CHO acetaldehyde or ethanol can give this reaction. Among ketones, only alkantuone. Or you can say that methyl ketones can give. Only methyl ketones can give this reaction, and among esters only, that is very important, only ethyl esters can give this reaction. Ethyl ester, that is also at high temperature. So these type of compounds can give iodoform reaction. So this reaction can be useful for distinguishing these compounds. Ethanol is primary alcohol. Among primary alcohol, this can give iodoform reaction. It is CH3CHOH group alkantuone. It can give iodoform reaction. CH3CH2CHOH, it is secondary but not alkantuone. So it is not answering iodoform reaction. It is compound having CH3CHOH group. So among the different compounds given, the third one, option C, is a compound, even though it is it is a secondary alcohol, it is not an alkantuone. So this compound is not answering iodoform reaction. Important. So option of this question is option C. Answer of this question is option C. Another one is identify the correct match. Very simple. No need of explaining this reaction. Phenol on treatment with chloroform and aqueous alkali followed by acid hydrolysis gives salicylaldehyde. This reaction is called Reimer-Tiemann reaction. It is Reimer-Tiemann reaction. So this is 1, 2, 3, 4. 1, 2, 3, 4. First one, Reimer-Tiemann reaction, that is C, 1 to C. Second one, chloroform when treated with fused with NaOH at 623 Kelvin and 300 atmospheric pressure, you will get sodium phenoxide that on acid hydrolysis giving phenol. This reaction is called Dow process. Second one is D. And the third reaction is sodium phenoxide on reaction with carbon dioxide forming sodium salicylate that on acid hydrolysis giving salicylic acid. It is Kolbe reaction. So third one is A. And last one, sodium phenoxide on treatment with methyl iodide giving anisole. It is an ether will be formed. Sodium phenoxide on treatment with alkyl halide produces an ether. This is Williamson's ether synthesis. So 1 to C, 2 is related to D, third one is related to A, and the last one is related to Williamson's in the B. So that is your option C. Option is C. Third one is your answer. This is your option. And next question is which of the following gives a tribromo derivative on treatment with bromine water? Options are given. All these are substituted among the 4 compounds given. 3 of them are phenol derivatives and 1 is benzyl alcohol. Phenol on reaction with bromine water, 2 forces tribromo phenol is formed. It is because of the higher activating power of the OH group. That is very important. So phenol can undergo electrophilic substitution reaction with the bromine water, or a tribromo derivative will be formed A tribromo derivative can be given by phenol only if both the ortho positions and the para position, both these are ortho and it is para, all these three positions are free. That is, all that these three positions are readily available for electrophilic attack. So in order to get the tribromo derivative from this phenol molecule, there should be no substituent at its ortho positions and para position. If you consider here in this phenol, ortho position is one of its ortho positions is connected with a CH3 group, so it can give only dibromo derivative. This bond does not undergo cleavage under this reaction condition. So here phenol, here one group, methyl group is there. So this one reaction with the bromine water gives a tribromo derivative only. Here you have to find out the one that can give a tribromo derivative. In this case, second one, it is metacresol, 3-methyl phenol, that is metacresol. Here, with respect to this OH group, these two ortho positions are not having any substituent. Para position is also free. So both the ortho and para position, this para position and both the ortho positions are free for electrophilic attack of Br positive. So this can produce as a tribromo derivative. So here the tribromo derivative can be given by this one. So answer of this question is option B. Okay. Next is, see the question number 8 to 12. Question number 8 to 12 consists of two statements, assertion A and reason R. Answer these questions selecting the appropriate options given below. Assertion reason type questions. See, first one, assertion is given as the bond angle COH in alcohols is slightly less than the tetrahedral angle. In alcohols ROH, in alcohol the oxygen atom is sp3 hybridized. So it should have a tetrahedral structure. In alcohol, that oxygen atom has got two lone pairs. Here around this oxygen atom, there are two lone pairs and two bond pair. Here the expected angle is 109 degree 28 minute, but due to greater here lone pair repulsion is stronger than bond pair repulsion. Because of this lone pair repulsion, these bonds are coming closer. As a result, bond angle is slightly less than tetrahedral angle. That statement is correct. What is the reason given here? Here the reason given is it is due to the repulsion between the unshared electron pairs. That is also correct. The statement is correct. Not only correct, it is the correct explanation of the assertion A. The reason is correct as well as the correct explanation for assertion. Both A and B are A and R. Assertion and reason are true, and R, reason is the correct explanation of A, then that is marked as A. So here it is A because here assertion is correct, reason is also correct, and that is the correct explanation of the for assertion. So here the option is A. Okay. Next one, next assertion question is primary alcohols do not react with the Lucas reagent at room temperature. Primary alcohols can react with the Lucas reagent only on heating. There is no reaction of primary alcohol with the Lucas reagent at ordinary temperature. That statement is correct. It is because at that ordinary temperature, it cannot form the transition state readily. That is the reason. Here the reason is Lucas reagent is a mixture of concentrated HCl and anhydrous zinc chloride. This statement is correct. Reason, the statement given in reason, that reason statement is correct. Assertion is also correct, but the reason is not the correct explanation. Reason is not the correct explanation. Both A, assertion and reason are true. And reason is not the correct explanation of A, then it is marked as B. B is your option. B is your answer, or option B is your answer. That is B. So you are familiar to answer assertion, reason type questions. Both assertion and reason are correct. Reason is the correct explanation, then it is A. Both assertion and reason are correct. Reason is not the correct explanation, then it is B. Another one, phenol is more acidic than ethanol, that is assertion. Assertion is indicated as A, and reason is ethoxide ion. Reason R, ethoxide ion is resonance stabilized. Which is more acidic? Phenol is more acidic when phenol is taken in water. It undergoes ionization to produce a phenoxide ion and H3O+. When ethanol is taken in water, it undergoes ionization to form ethoxide ion and hydronium ion. Both these compounds undergo ionization in water. Phenol is more acidic because the acidic strength proportional to the stability of the conjugate base formed. You know that phenoxide ion is far stable than ethoxide ion because phenoxide ion is resonance stabilized. No such resonance is possible in the case of ethoxide ion. Not only that, ethoxide ion, in ethoxide ion, due to the plus I power of the alkyl group, higher will be the electron density around that oxygen. So you have to remember that phenol is more acidic. Phenol is more acidic than alcohol, ethanol. Can I get these slides? Which one? A slide. So this is what is given here is assertion that is given as A, that is phenol is more acidic than ethanol. Reason R, ethoxide ion is resonance stabilized. These are the two statements given. See the slide. Here assertion is correct. Phenol is more acidic than ethanol. That is correct. Very correct, because phenoxide ion is more resonance stabilized. Phenoxide ion is resonance stabilized while no such resonance stabilization is possible in ethoxide ion. So here assertion is correct. Phenol is more acidic than ethanol, that is correct statement. Reason, ethoxide ion is resonance stabilized, that is wrong. Ethoxide ion, in the case of ethoxide ion, no such resonance is possible. So here assertion is correct. Assertion A is true, but reason R is false. So the option of that question is, the answer of that question is option C. Among the assertion reasons type questions, if assertion is correct, reason is also correct, and reason is the correct explanation, then it is marked as A. If assertion is correct, reason is also correct, but reason is not the correct explanation, then it is marked as B. If assertion is correct, here assertion is correct, phenol is more acidic than ethanol. Reason, ethoxide ion is resonance stabilized, that statement is wrong. A is true, assertion is true. A means assertion, assertion is A, reason R, assertion is true but reason R is false, then it is named as, it is marked as P, marked as C. Option C is your answer. Another one, next assertion type question, the major products formed by heating methyl benzyl or benzyl methyl ether. While naming the common name, there is no need of mentioning the groups in the alphabetical order. It is methyl benzyl ether. When methyl benzyl ether is treated with the concentrated HI, the products, the major products formed by heating methyl benzyl ether with a concentrated HI are methyl iodide and benzyl alcohol. Is it true? See, remember this is methyl benzyl ether. Ethers are less reactive compound, but under drastic conditions they can react with hydrogen iodide. Remember, if any one of the hydrocarbon group is tertiary or benzylic, here it is benzylic. If any one of the groups is tertiary alkyl or benzylic group, then the reaction proceeds through SN1 mechanism. Here carbocation is formed. Otherwise, the reaction proceeds through SN2 mechanism. When it is treated with hydrogen iodide, first step protonation. Then this bond undergoes cleavage. This bond undergoes cleavage, giving methyl alcohol and benzyl carbocation. This benzyl carbocation will be attacked by I minus to get benzyl iodide. So in this reaction, the products formed are methyl alcohol and benzyl iodide. Very important. It is proceeds through, this reaction proceeds through SN1 mechanism. So here the product should be methanol and benzyl iodide. What is given here is methyl iodide and benzyl alcohol. This is wrong. This is false. It is wrong. Reason is methyl carbocation is less stable than benzyl carbocation. That statement is wrong because methyl carbocation is, that statement is correct, but that is not the methyl cation is less stable than benzyl cation. This statement is correct, but that is not the explanation of that one. So the product obtained is what? Product obtained here, the assertion A is false. A is false and reason R is true. While answering this type of question, you should be very vigilant. Otherwise, you may get confused. Read the passage again and again and try to answer the question. Here, the option of this question is option D. Next one is assertion. Simple one, both the that you have to answer. Both symmetrical and unsymmetrical ethers can be prepared by Williamson synthesis. That is correct statement. Reason, the reaction involved, the reaction is, the reason given is, the reaction involves SN1 mechanism. Symmetrical and unsymmetrical ethers can be prepared by Williamson synthesis. That is assertion, that is A, that is marked as A. And reason R is this Williamson synthesis involves SN1 mechanism. This Williamson synthesis means reaction of an alkyl halide with sodium alkoxide. It is SN2 attack of an alkoxide ion to an alkyl halide. So better result is obtained. The alkyl halide is primary. So here the reaction proceeds through SN2 attack, SN2, this reaction proceeds through SN2 mechanism. Here what is given is SN1 mechanism. That statement is wrong. Here assertion is true. Assertion is true and reason is false. In such a case, your answer is option C is your answer. Option C. Assertion and reason type question, you have to practice many more number. Next is analogy type question. The reaction of Grignard reagent with methanol. Methanol is formaldehyde. The reaction of Grignard reagent with methanol produces a primary alcohol. Grignard reagent with any aldehyde, Grignard reagent with formaldehyde or methanol produces a primary alcohol. That statement is correct. That is the reaction of Grignard reagent with methanol produces primary. If so, the reaction of Grignard reagent with the propanone. Propanone is acetone. Propanone is a ketone. You know that when a Grignard reagent reacts with the ketone, the product is what? You know the answer. The product is tertiary alcohol. Option B is your answer. Next question is another analogy type. Here one ester, one oxo ester is given. It is methyl 2-oxo cyclohexane carboxylic acid derivative. It is an ester that on treatment with sodium borohydride product obtained is that one. See, remember during the reduction reactions of sodium borohydride reduces only aldehydes to primary alcohols, ketones to secondary alcohol. It's a ketone. The CO group becomes OH group. It is never reducing the ester group. It becomes as such. That is given. And the another question is what? If so, the same molecule on treatment with lithium aluminium hydride. Lithium aluminium hydride is a versatile reducing agent. It reduces almost all the functional groups. It reduces carboxylic acids to primary alcohol. It reduces acid anhydrides. It reduces esters. It reduces amides to primary amine. It reduces acid amide, acid chlorides. It reduces acid chlorides. It reduces nitriles. It reduces aldehydes. It reduces ketones, etc., etc. Here it is lithium aluminium hydride. It is an ester. It becomes CH2OH plus methanol, and this keto group, the lithium aluminium hydride reduces both the ester group. This ester group becomes CH2OH plus methanol, and this keto group becomes OH group. So the answer, the product of this reaction is this keto group becomes secondary alcohol. This ester group CH2OH plus methanol. So answer of this question is, this is the answer. Option C is the answer of that question. Option C. Next one is see another analogy type. When you treat phenol with NaOH, the product obtained is sodium phenoxide. That sodium phenoxide on treatment with carbon dioxide followed by acid hydrolysis gives salicylic acid. That reaction is Kolbe reaction. If so, phenol on treatment with chloroform and alkali produces a compound X. That on treatment with NaOH giving Y. That on acidification produces Z. So you know that this reaction is what? This reaction is Reimer-Tiemann reaction. It is Reimer-Tiemann reaction. The product obtained is orthohydroxy benzaldehyde or salicylaldehyde. Here the answer is salicylic acid. There the answer, the reaction of phenol with chloroform and alkali followed by treatment with aqueous alkali, and then acid hydrolysis giving orthohydroxybenzaldehyde. You can expect one question from this part. Here first product you will get X is what? X is substituted benzyl chloride is formed. That on treatment with this is X. That on treatment with NaOH, these two chlorine atoms are replaced by OH group. Two OH groups are on the same carbon atom. That removes a water to get CHO group. So substituted benzaldehyde is formed. This one acidification produces salicylaldehyde, orthohydroxybenzaldehyde. So answer of this question is its answer is 2-hydroxybenzaldehyde or salicylaldehyde. So option is D. And another one, acidic strength of nitrophenols. Acidic strength of nitrophenols is given as para-nitrophenol is more acidic than orthonitrophenol, more acidic than metanitrophenol. Phenol is acidic. Phenol is acidic because phenoxide ion is resonance stabilized. Phenoxide ion is resonance stabilized. Presence of electron withdrawing group increases the acidic strength of phenol. NO2 group is electron withdrawing group that increases the acidic strength. The para-nitrophenol is more acidic than orthonitrophenol. Normally, orthonitrophenol should be more acidic than para-nitrophenol. But in orthonitrophenol, due to the presence of intramolecular hydrogen bonding, that becomes less acidic. So para-nitrophenol is more acidic than orthonitrophenol, more acidic than metanitrophenol. That is given there. If so, acidic strength of cresols. Cresols are hydroxytoluene, or it is hydroxylated toluene, or phenol with a methyl group. Methyl phenols, orthocresol. This is orthocresol. It is paracresol and metacresol. Here you have to remember this one. You have to know the pK values. Orthonitrophenol, the metanitrophenol, its pK value is pK equals 10.2. pK value of orthocresol 10.1. Para is also 10.1. Acidic strength of various compounds can be compared by knowing the pKa values. All these values are given in your NCERT. Higher the Ka, lower the pKa, higher the acidic strength, lower the Ka, higher the pKa, lesser the acidic strength. So here it has got acidic strength 10.2. It has a higher pK value among these one. Higher the pK value means higher the pKa. Ka value, higher the Ka, lower the pKa. Higher the Ka, lower the pKa. Here, lower the pKa, which is more acidic. Here, the acidic one is ortho. Here, the acidic strength of which is more acidic. The one which is having less metacresol has 10.1 pK value. These two have 10.2. Lower the pKa, higher the Ka, higher the acidic strength. So metacresol is more acidic than both orthocresol and paracresol. They have same acidic strength. These values you have to remember. Cresol's pK value is ortho 10.1, meta 10.1, ortho 10.2, para also 10.2. Here one is the one which is having lower pK means 10.1. So it has higher Ka, that is more acidic. Option A is your answer. Option A is your answer. Option A is your answer. And next one, 17th one, another simple question. You are provided with an alkene. that alkene on treatment with acid hydration giving an alcohol. Here first step CH3, CH3, CH double bond CH2, this on protonation, electrophilic attack H positive ion, H plus is coming here, you will get a carbocation. This carbocation is secondary in nature. It has a quaternary, it has a primary carbon as well as a tertiary carbon. One of its adjacent carbon atoms is tertiary. So there is hydride shifter, H minus ion is coming to this side. Hydride shifter, so it becomes CH2 and it becomes C positive. You will get a tertiary carbocation that will be attacked by water followed by deprotonation giving this product. If so, during the hydration of alkenes, first step formation of the carbocation. Carbocations can undergo rearrangement if possible either by hydride shift, methyl shift, etc. In this case, if so, in this case CH3, see this is the alkene given, this is the alkene given, this on treatment with this on acid hydration, first step electrophilic attack H plus ion to form a carbocation. Here it becomes CH3, here it becomes CH positive. Now it is secondary carbocation, adjacent carbon is quaternary, there is methyl shift as result. Here there is CH3 group, now it becomes a carbocation. Finally, water will be attacking here, followed by deprotonation giving this alcohol. So here 2,3-dimethyl butane 2-ol, 2,3-dimethyl butane 2-ol. This is 2,3-dimethyl butane 2-ol. This is the answer of this question. Important. Cation is formed that undergoes rearrangement. Option A is your answer. And another one, read the passage given below and answer the following questions. See, go through this passage. Williamson synthesis is used for the preparation of both symmetrical and unsymmetrical ethers. It involves SN2 attack of an alkoxide or phenoxide ion on an alkyl halide. Better yield is obtained if the alkyl halide is primary. Tertiary alkyl halides undergo elimination reaction. Di-tert-Butyl ether and di-aryl ether etc. cannot be prepared by this reaction. Ethers are least reactive in nature. Under drastic conditions, they react with hydrogen acids. They react to the HX to form alcohol and alkyl iodide. If the ether contains one tertiary butyl or benzyl group, then the reaction proceeds through SN1 mechanism, and in other cases, the reaction takes place through SN2 pathway. Go through this passage and answer the following questions. Which of the following reagents when heated will give a better yield of ether? Very simple. Williamson synthesis. You have to answer this question on the basis of Williamson synthesis. Better yield is obtained. The alkyl halide is primary. Here C2H5I is ethyl iodide. It is a primary alkyl halide and sodium tert-butoxide. So very clear, this is your answer. Option A is your answer, and you can expect question from this Williamson synthesis. And another question is benzyl isopropyl ether. Benzyl isopropyl is C6H5 CH2. Benzyl isopropyl group, this one. This is benzyl isopropyl ether. When reacts with hydrogen iodide, very simple. If one of the hydrocarbon group is benzylic or a tertiary, then reaction proceeds through SN1 mechanism. It becomes protonated first. It becomes protonated. This bond undergoes cleavage. you will get a benzyl carbocation that will be attacked by I minus ion. So benzyl iodide and CH3 twice CHOH isopropyl alcohol, C6H5 CH2I and CH3 twice CHOH. This is your answer. Option B is your answer. Okay, we can give. ഏതൊക്കെയാണ്
ഈ സ്ലൈഡുകളെ അവർക്ക് കൊടുക്കുമെന്ന് വെച്ചിട്ടുണ്ട്.
ഏത് സ്ലൈഡുകളാണ്?
ഈ നമ്മുടെ ഇപ്പൊ സാറൊക്കെ PPT-യിലെ അപ്പൊ ഞാൻ ഓണാക്കാം സാർ.
I will contact with the concerned authorities and I will.
സാർ ഒന്ന് പറയാം.
Okay. One more question. See, one more question. Which one of the following cannot be prepared by Williamson synthesis? Williamson synthesis is not used for preparing if the ether contains two tertiary alkyl group as well as two aryl group. That means anisole can be, anisole is methyl phenyl ether. It can be prepared by Williamson synthesis. It can be prepared. Phenol is phenol can be prepared by this is ethoxybenzene. Phenol can also be prepared by this reaction. Benzyl ethyl ether, benzyl ethyl ether. This is C6H5 CH2O CH2 CH3. It can also be prepared by Williamson synthesis. Williamson synthesis fails to prepare ditert-Butyl. It is ditert-Butyl. Ditert-Butyl ether cannot be prepared by this method. Also, diphenyl ether cannot be obtained by this method. So here the answer is option D. Okay. Yes. Hello students. Can you speak? I will contact with the concerned authorities and I will make arrangements for getting these slides to you. Okay. I will find out a solution for that one. Try to go through these questions. All are highly standardized questions. Go through these questions. I think if you go through these questions, you will get a nice idea regarding this chapter, alcohols, phenols and ethers. Wish you good luck. Thank you very much.